Hello? Yeah, Mr. Neelis, we can see your screen. Please go ahead.
Good evening, all of you, and welcome to the session on cloud-based storages on Windows Azure platform. I understand this is one of the series that is happening by TechGig, and then we'll today focus on different storage mechanisms which are available on Windows Azure as a platform. So the plan that we have in place for today is we'll talk about various cloud options, and towards the end we'll see a demo. As mentioned by the moderator, you can send in your questions in between the sessions. As we have a limited time and we have an audience of varied experience, I would prefer looking at the questions towards the end of the session and try my best to answer all of the questions that come in this particular forum. The first point I think we need to discuss out here is why do we need to go ahead for storing our information, storing our data onto the cloud. There are few important factors that really decide when, how, and why should I go ahead and look out for a storage which is available to me on the cloud. The first very important aspect is on the scalability. Today, many enterprises host data onto their enterprise data warehouses. For medium and small enterprises, the scalability becomes the issue. Investment in hardware, investment in maintenance is what is key that one will have to look ahead when we want to maintain data on premise. Now that's a very important thing, that when we go to the cloud, we get a
sorry for intervening.
We get a scalability.
Your voice is breaking in between. Can you please check?
Okay. Is it better now?
Yeah, it seems much better now. Please go ahead. Thank you.
Okay. So I was referring to scalability. When we talk about cloud storage, scalability is a prime factor in moving our data onto the cloud, because when we look at this point, we actually get a on-demand scalability. We can scale up, we can scale down depending on the load and the data that our application is going to experience. So on-demand scalability is a very key thing, is a key factor to move or to decide on the storage strategies. The second important point is the availability that we get when we go to cloud. I don't say we don't have high availability on our enterprises on premises, but when we go to cloud storages, the availability factor, the SLA that a vendor cloud provider wants to give is very high as compared to what SLA we may want to maintain on-premise applications. So scalability, high availability are the factors that we achieve when you go for cloud storages. Third and important point is about pay for what you use. This is a concept that comes from utility computing, where we need to pay for what we use. From a data perspective, we need to pay only for how much data we store. It is not like a traditional option where we get, say, 10 terabytes of space and we pay for the entire space irrespective of how much we use. But here, various cloud providers in competition will charge you only for how much data you store on their data centers. Towards the end of the session, we are going to have a look on how is the metering and the pricing model given by Microsoft on the data that you store in Azure. Then comes on priority, as per my perspective, is manageability of your data stores. On-premise will have to have special security infrastructure. You'll have to have manpower to maintain it, whereas when it goes to cloud, we do not have to depute that effort in managing your storage. On this front, I would like to also highlight another point about provisioning. When you talk about creating a new data store, or you want to modify the existing data store, the manageability becomes a key factor through the resources that a cloud vendor will provide to you. When you talk about Windows Azure, you will have a management portal through which you can provision your servers on the fly and then start using the servers in the next couple of minutes without having any major setup required for you to do. I'm going to demonstrate that as well. How do you go ahead and create a storage account, or how do you go ahead and start using a storage account on your cloud? Then comes the option where you go ahead and you want to access your data in multiple ways. Today, there are applications which are running on premises which will use some client libraries which are there provided by various vendors. You may want to use REST. So when you move your data to the cloud, you'll have to think over how your existing applications which were using some client libraries, or maybe which were using the REST APIs, how are they going to go ahead and migrate your applications on the cloud using the existing application setup. Many times we also access our data which is on our file system through standard NTFS APIs. Windows Azure will provide you all these three options. When we talk about having something like SQL Server on the cloud, you can use your standard libraries to access SQL Server on the cloud. You can store images, videos. For that, you can again use client libraries provided by Azure, or you can even go ahead and use REST. So this is what we are going to look ahead in this particular seminar, and along with that, the demo that we are going to look at. Moving ahead in going deep into the topics now, when it comes to Windows Azure, as you all know that Windows Azure is a cloud computing platform from Microsoft. There are many things that Azure will provide you, but our focus for today in this particular seminar would be only talking about the various options Windows Azure provides you for storing your information, storing your data. So then the question comes, why do we require multiple options? There are applications which may use relational data store. There are some applications wherein you don't want to have relational data store, you want to store huge information in forms of files, could be videos, audios. So to accommodate all these things, Windows Azure provides you two types of storage services. One is your Windows Azure storage service, and the second service that you see is your SQL Azure. So on Windows Azure storage service, you have 4 options to go ahead and store data. You have blobs, queues, tables, and Windows Azure drives. I repeat, Windows Azure storage is further classified into Blob Service, a queue service, a table service, and Windows Azure drives. All these 4 options will allow you to store information in a non-relational fashion. So if your application demands that you have huge information in a non-relational format, Windows Azure Storage Services is the best option for you to go ahead and implement the data storage using the suitable options from this 4. If you want to go with a standard SQL Server or a relational store on the cloud, people who are using SQL Server for on-premise hosting can migrate their application to SQL Azure on the cloud. So let's get started. Having known the various options that you have now, let's get started with understanding what and when do we go ahead and use these particular stores. So by now you definitely would have some questions on when do we prefer which storage. What options should I choose when I want a specific thing to store? So here is the answer to most of your questions. In Windows Azure Storage Services, first one to go with now is the blobs. Now if you have unstructured binary or let's say text data files, you can go ahead and store or upload it into blobs. The best example which I can give is probably you want to create a media library, create a photo example where you want to upload photos, you want to upload videos and create a video library on the cloud. That's where your binary data would go in. So blobs would be the best option for you to go ahead and use different types of blobs to store audio, video, or any other unstructured binary and text data. Queues. So people into this webinar definitely would be aware of the way queues works. Various products which are available on-premise from various vendors. One is MSMQ from Microsoft. You have WebSphere giving product like WebSphere MQ. So on the cloud as well, when you want to communicate between roles. In Azure, you have 3 types of roles: a web role, worker role, and a VM role. So the intercommunication between these roles can happen through queues. Also, if you want to do some batch operations and you want to post some updates to the worker role or to a batch process, you can send in messages onto queues. So queues typically, which is a part of Windows Azure Storage Service, can hold messages which can be read, processed, and then deleted. Further comes the table service. These tables are not identical to the tables that we have in traditional RDBMS. The main difference here is these tables are non-relational tables. So if you have some non-relational structured information to be stored, then Windows Azure tables is the best choice that one can go ahead. Then, okay, before that, let me quote another example here. I'm sure most of us use Facebook. So a typical Facebook application where we keep sending some friend requests, so that could be best done through queues. You send a friend request, it goes into a queue. Similarly, when you want to post some comment, you want to post some update, that goes as non-relational structured data in forms of tables, and we want to upload our photos, we want to upload videos, that stuff can go into blobs. So together, blobs, tables, queues can work together and be used to have a backend for your applications. Windows Azure Drives is another good option. On our local machines, we go ahead and mount, or we go ahead and add VHDs, we go ahead and add drives. Similarly, if you have a role running in Azure, on that role you can mount a drive. You can mount an NTFS volume on the cloud, which will be accessible to the role in which it is mounted. So these are various options. As we move ahead, we will touch upon all these 4 options. I'll show you a sample code on how do we write a simple application for blobs, queues, and tables. For SQL Azure, I need not say much because it's a RDBMS which is available on the cloud. So to get started, the way it is structured is to go ahead and start creating or working with Windows Azure or SQL Azure. What we need basically is, if I go the bottom up on the slide, what I require here first is storage account. So if I want to work with blob, tables, queues, or drives, I need a storage account in Azure. Similarly, if I want to work with SQL Azure, what I need is a database server on Azure. So how do we go ahead and create a storage account? So you can go to my Microsoft.com site and register and subscribe to have access to Azure for one of your live IDs. The point here is, if you see on the slides as well, the key is through your live account, you can get access to various services available on Azure. So your live account has to be enabled. What you need to provide is your credit card number to get a subscription active for your live account. So I have a live account which I'm going to use for today's demonstration. So the developer portal is windows.azure.com. So this portal will ask you to log in with a live ID. I have already done that, so for me probably it will not ask. It will directly use the password just saved and log on to this. So this is a management portal through which you can provision your servers, you can provision your account, you can provision your services. So today we are not dealing with services at the scope of this particular session. I limit the scope only to storage account and database servers. Now here you see on the screen you have an option of creating a new storage account. The storage account will have options for you to go ahead and use blob, tables, and queues. Whereas if you go to a database server, this is where it is going to go ahead and create a SQL Azure database server for you. So if I come back to the slide, that's what you have. So through your live account, you'll have to get the active subscription, and in the subscription you can create a storage account, or you go ahead and create a database server for that. So let me start and create something, a storage account for you. So I'm going to start creating a storage account with some domain name. So I'm going to create a storage account. I'll use a proper subscription, and then probably the storage account could be a techgeek demo dot the further details that you have. So this looks like it's already been used, so I probably would use some different name, and then in which area of the Microsoft Cloud I should be creating this particular storage account. So I choose the region as Southeast Asia, and I say okay. So this is as simple of creating a storage account. As I told you earlier, using Windows Azure, it becomes very easy for us to go ahead and manage a account on your cloud. So in another 1 or 2 minutes, this account will be provisioned for me. This is what I was referring to as easy manageability through Windows Azure portal. Similarly, while this gets created, we can go ahead and create a new database server as well. So let this get created. In the meanwhile, we'll go ahead and continue with the further topic on the slides. So if you have any questions, as I mentioned earlier, please do posting the questions to the moderator so that towards the end I'll answer all of them. Now coming to blobs. How does the blob basically work? Now you can see here the first vertical you see as account. Just now we have created an account with some name. You can see the account name that gets created is TechGeek NW demo, and you will see, so the final URL of your blob will be techgeeknwdemo.blob.something. Similarly for tables, you have the same URL with tables. For queue, you will have the same URL with your queue as your intermediate suffix for this. So this is the account. So under one account, the way blobs are categorized or clubbed together is via the container. So your account can contain multiple containers, and every container will have set of blobs. So here in my demo, which I'm going to show you, I have an account with name nnwordk, has two containers, one container to store pictures, another to store videos, and further I'm going to upload images as blobs into container. In the second container of videos, I'm going to upload videos as blobs into containers. So this becomes the structure of your blob. For accessing, the access can happen through REST. The access can happen through the storage client APIs provided by Windows Azure. So this is how it looks like. So the complete URL for this situation will be like nnwordk.blob.core.windows.net/fix is the name of the container / the name of the blob. This is how a blob will be accessible to applications. This is how the blobs will be accessible to people through REST. I hope it is pretty much clear. So your account is getting created. Great. So the account has got created. So in this situation, the account name will be techgeeknwdemo.blob.core.windows.net/fix, the name of the container / name of the blob. Now once you have the account and you now create a container for the blob, let's see the architecture, or let's see some important points how blobs work. So blobs are further classified into two types. First, the block blobs. The block blobs are optimized for streaming. So the information like images, videos are best suited to be uploaded as block blobs, because you may want to stream that when it is sent to your applications or the clients. However, when I say a block blob which is less than or equal to 64 MB in size can be straight away uploaded using the put blob operation, which is available via REST as well as the storage client API. But the block blobs which are greater than 64 MB would have to be split into small sections which are called as blocks. Each block can be up to 4 MB in size, and then these blocks, once they are uploaded successfully in sequence, can then be assembled to form a blob. I repeat, block blobs which are up to 64 MB can be uploaded straight away using a put blob operation, while the block blobs which are more than 64 MB has to be split further into small chunks, which is called as blocks, which will be of size 4 MB, and once all the blocks are uploaded, you can sequence them for assembling into a blob using another API which is put blob list. I don't want to go deep into the code in this seminar, but I thought it should be useful to you just to know how blobs will work. So you have a blob, which are optimized for streaming. Next on the cards comes is your page blob. So page blobs are basically optimized for random read-write operations, and you don't have a limitation on this. So it's a huge size that a page blob can contain. So let's see what is the limitations or what are the data points for a blob as well as for a page blob. As referred earlier, this is a summary slide for you. As referred earlier, we have blob, which is optimized for streaming, and page blob, which is optimized for random read-write operations. So when it comes to the blob, the size which can be there is up to 64 MB for a blob in one piece, or you can have blocks of 4 MB each, and then further go ahead and assemble multiple blocks as blobs. You can see the huge size that you get when you are working with blobs. A blob can be up to 200 GB in size, or can be a collation of, or can be assembled from up to 50,000 blocks, whereas a page blob can be of size up to 1 terabyte. That's really, really huge. The API that you use is pretty well listed out here. You have a concept called a storage emulator. When you work with Windows Azure, you cannot afford to always work on the cloud. You have an option to install storage emulator on your development machine, which could be Windows 7 or equivalent, and then you can test your applications locally without uploading that onto Azure platform on the cloud. So the limitation for that is up to 2 GB of size. So quickly go through on the sample code. This is how the structure of my seminar would be. I'll talk about a storage option. I'll give data points about that. Then I'll show you a sample code, and then we move next. So about blobs, now you know that blobs are of two types, page blob as well as blobs. So if you check out here, what we have is, here we first go ahead and create a storage account. Now this code, people who are working on .NET or any other computing platform, you would see that there is something like achieving or referring to a connection string. So you will have a 512-bit key, which I have not put here, but that's how the complete connection string for your storage account will be. So the protocol to be used, the account name, and the account key. So here is what you have. For gig, you have this as your account name, and the account key is where you can copy this account key from here, and that's what is the access key for your application. So once you have access to the storage account, the next thing you'll have to create a blob client using a storage account, which will be used to do all the operations on your blob. So if you see here, the next step 2 is what we create a client through which you can go ahead and then create a container. I've already shown you earlier that in the hierarchy you have an account, you have a container, and then you have a blob. So using the client, you get a reference to the container. So you go ahead and try to create a container with the name pix, and you create a container if it's not existing. If the container is already existing, you refer to the container. Once you have the container, you go ahead and then create or upload a file as blob. Here I decide that I want to go ahead and create a blob. I have an option that I should choose to go ahead and create a page blob or a blob. Here, as I wanted to upload an image, I went ahead and chose blob to be created. So I'm creating a blob with this particular name, and the file from my local machine will be uploaded onto the cloud at this location onto the blob in Azure. So this becomes how do we upload it. Similarly, if you want to download a particular file or download a particular blob into a file locally, so you can use this particular APIs to download this particular blob into the local file onto your machine. And obviously in a similar way you can go ahead and delete it. So this is a sample code which you can refer to. How do we go ahead and create an account, then use a client. Using the client you create a container, upload, download or delete a blob. So this was a very short introduction about what a blob is, when do we use a blob, and a quick code snippet on how a blob code will look like. Moving ahead on to queues. If you recollect what I said earlier, queues normally are used for asynchronous processing, one. Second, they are used for inter-role communication. Azure will have web roles which are end-user facing, whereas it will also have worker roles which will work as background processes. So queues is one of the best choice that one can make if you want to send some actions, if you want to send some commands, or you want to send some logs from your web role, which is UI specific, into your background processing, which is into your worker role. So the structure remains the same. Here in queue you again have an account. Under account you will have a queue, and under queue you will have messages. So here for TechGeek demo, this becomes your queue URL, whereas this becomes the account name which you have already given. So you have a queue that is there. You have an account under which you can create multiple queues. So in this particular screen scrap, what you see here is you have two queues which are created to hold various messages. The first queue that you see here is to hold messages which are coming from a web role. Web role is a UI specific application. So those messages which you want to pass from a UI into your worker processes that are to be put into the UI actions in my particular demo. Whereas if you do some logging activity, those messages can come under this particular queue. So queue will hold messages. You have account which will have multiple queues, and every queue further will have various messages. If you look at the URL at the bottom of the slide, the URL is pretty much the same except the last part. So here, what you see here, the important thing that you should be noting is you have a queue, then this is what is the queue name, and further you will have messages which can be retrieved using REST or your client APIs. To work with queues, logically you can have unlimited messages that you can keep posting onto your queue. The limit could be the size of your list storing that particular messages. Every message today can be of 64 KB. Earlier, in the prior versions of Windows Azure, this limit was 8 KB. Looking at the need, this limit of 8 KB per message is now increased to up to 64 KB per message. As I told you, typically messages are used to communicate instructions between various applications, so we need not store huge data. In case you need that, you need to store some information. What typically is the practice that people follow is you will just give a metadata or a pointer into the queue, whereas the actual object can remain into your blob. So you read the blob URL from the queue and then pick up the object from the blob and then start processing it. One very important thing that everyone should be noting here is when you work with MSMQ, you read a message, that message is removed from the queue. Here, the messages are not deleted after your read operations. The application which is reading the message should explicitly delete the message after processing. So in simple words, here message consumption is a two-step process. One, you read the message, process it, and once the processing is complete, you then go ahead and delete it explicitly. Now, why this is done? Now, on the cloud, there could be multiple worker roles who will be accessing your messages simultaneously. So what happens here is sometimes processing might get failed in between, and we don't want that the message processing is incomplete. So by default, every message will have a specified visibility timeout. So as soon as you read a message, the message becomes invisible to other people who are looking from the queue for a specified time. For instance, if application A reads a message, it will be made invisible, let's say, for 30 seconds. So when the second application tries to read the messages from the queue, that message will be made invisible for 30 seconds. After 30 seconds, if the message is not deleted, that message becomes visible again to anyone who reads from the queue, which means the idempotent behavior which is required to be there for your messages is to be implemented by the application reading the messages. So this is how a queue code would look like. Now you would see some similar things which will happen in all my code snippets. The first thing that you will always see is the storage account, which you will refer to a specific storage account on your cloud. Second step, though similar, slightly different. Earlier we had used storage account to create a blob client. Here I'm going to use a storage account to create a queue client. A queue client is a class which I'll be using to work with messages. I want to create, I want to add, I want to read, I want to delete messages. Queue client is what is going to help me to achieve that task. So using the client, the next step would be to go to the next vertical that you saw in the figure. The next vertical was for queues to get created. So using the queue client, what we do is we go ahead and create a queue here. So UI actions, you already seen this particular keyword earlier in my figure. So UI actions is the queue which I have created. In case the queue exists, it will be referring it. In case the queue is not existing, it will create a queue and send me a reference to the queue client. And then I create a message object, and that message is added to the queue. Similarly, if you want to go ahead and read messages from the queue, you just have to say queue.getMessage. The getMessage method will always return you the message which is available as the first message in the queue. So as I told you earlier in the previous slides, it would happen that some messages are read twice in case they are not deleted after processing. So getMessage will give you the first message which would be popped out of the queue, and you can read the information from that message. Similarly, you can do delete operations. So this sample code snip will give you an overview of how do we create a queue, then how do we create messages, how do we add a message, how do we read and delete the messages. I hope this is understood to all of you. Then the next part is the tables. I repeat, these are Azure tables. These are not our relational tables that you see in SQL Server or any other RDBMS. So here you have an account. Under account, you can create tables, and under tables, you will see entities. Here, table will not have rows or columns that we normally see. Azure table is composed of entities, and entities is further composed of key value pairs, and that is why I call it as the schema is not fixed. Every entity can have a different set of key value pairs. So let's look at the details of Windows Azure tables. When you work with tables, the data is stored in form of entities. In the bracket, what you see here is the similarity which I wanted to draw between Windows Azure tables and relational tables. So when I say the data in Windows Azure is stored in form of entities, you can probably want to compare that in RDBMS to what you have rows. So you have multiple entities in the table the way you have multiple rows in a RDBMS table. Every entity is a set of properties. A property is a key value pair, and that's where I can draw some parallelism to columns. Now every entity is 1 MB, while the table can grow up to 100 terabytes. Again, a huge size to have. At max, a particular entity can have 255 properties, and those 255, this 255 number includes the 3 system properties which are added by default. These properties are partition key, row key, and timestamp. These are the 3 system properties that you will see in each and every entity of your table. Why are they used? So the system properties, these names that you see here, names are reserved, and these names you will not be able to change. Okay. So it will be a responsibility of the code or developer who is using the table to make sure that when you insert and do update, you provide appropriate partition key and row key values. However, the timestamp values are automatically managed by the storage. The timestamp gives you when that particular entity was last modified. You cannot go ahead and do a change on that. However, for partition key, code will have, or the developer will have to provide proper values to it. So the complete entities of tables are actually organized by partition, and this is used in, the partition key is used in combination with row key to uniquely identify a particular record. In Azure terms, I can say to uniquely identify a particular entity. So partition key and row key together has to be unique. So to quote one example from could be, again uploading images. The partition key could be the name of the logged in user, whereas the row key could be the name of the image. So for that user, that particular image ID always remains constant. So partition key and row key together always are unique. The maximum size that a partition key and row key can have again is 1 KB. For both it is 1 KB. Now the various types which are supported in table storage, you will have int32, int64, string, double, datetime, boolean, binary. So if you see, most of the standard data types that you require are supported by the table storages. So if you want to see how it will look like, it's a 2-step thing that I want to explain to you all. So the way tables, the code that, the way you'll have to work with tables is, the first you'll have to create a mapping of what you want to store. So this is like an entity model that you'll have to work with. So you'll have to create a class which is from the table service entity, and this entity class will have a mapping of all the values that you want to associate or you want to add into the table. So if you see here, for example, I'm adding actually 5 values to my table. So in a traditional RDBMS table, you could have 5 columns. But here, what you have is I'm storing a nickname, a string, caption, then I'm storing the photo URL, and along with that, what I do is my partition key is the album. So the albums which I create becomes my partition key, and every album will have various photos. So as mentioned earlier, partition key and row key, it is the responsibility of the code and the developer to make sure that appropriate values are assigned to it. So here I don't have to create another properties for album and photo ID. I simply assign album and photo ID properties to partition key and row key uniquely, so that in every album I have a unique photo ID. So you have this photo entity class which works as entity mapping for me for my table storage, and then comes the standard processes, standard steps that we follow. To start with, getting a reference to the storage account and creating a table client are the standard steps that you might have now seen for blobs, for queues, and now again for the cloud tables. So I use the table client to create a table with the name photo book, and then to actually go ahead and access the entity class, what I use is I use a table service context class to go ahead and add, remove, or update my entity objects. So the table service context class object is going to give me properties like the methods like add object, update object, delete objects, and save changes. So what basically is happening here is I'm creating a new object of photo entity where I pass the mandatory values and other details, and this entity object I'm passing it to the service context, the add method object, and then I say save changes. As soon as I say save changes, that's the time where your information gets pushed back into your table storage. Similarly, if you select something, I'm using link here, so people comfortable with link can really understand it pretty fast. So I'm using a link query to get the entity object which has the partition key as this and photo ID with some value. Right now I've hard-coded the values, but this could come somewhere from the UI, and then I get the entity object. So this is how I can go ahead and select a entity from my table storage. So we have seen how do we insert the entity, we have seen how do we select the entity. In the same fashion, while I inserted the entity, I didn't have the nickname. Now I am updating the nickname onto the entity and then updating it back onto it. This update will not happen till I don't fire the save changes. The save changes method of the service context is actually going to push these changes to the table storage in Azure. Similarly, you will have something on the delete object as well. So that's about the tables. Coming to the last part from the Windows Azure storage is the Windows Azure drives. Now Windows Azure drives are similar to the drives that you map onto the storage as well as the local thing. So what basically we do is we upload the drive into a page blob. So the data of the drive is stored into a page blob, and it can optionally be cached into the local resource into your role. So the data is persistent here. Data is not volatile because it is stored into the page blob. So even if your Windows Azure virtual machine recycles, restarts, your information of your drive remains into your role. When the role restarts, because it's going to refer back the page blob which has the complete information of your drive. Now this drive can be mounted into your roles with the help of the cloud drive class, and once you mount it, it will be accessible via a drive letter. So similarly, the way when we use USBs on our laptops, you get a drive letter. In a similar way, when you mount a BSD onto Azure, you will have drive letters assigned to it, and then you can go ahead and use standard NTFS file IO APIs to access the contents of Windows drive, just like you go ahead and access content from your local file system. So Windows Azure Drive that way helps for existing application to quickly mount it onto Windows Azure with the help of Azure drives. So if you see the way it looks like, important points to highlight here is from a storage account, what you do is you go ahead and create a cloud drive, and cloud drive will point to some URI which is for your page blob, and then you create a drive. If it is not existing, here I am specifying that the drive should be of 5000 MB, and then once the drive is created, I am mounting the drive. After the successful mounting of the drive, it returns me a drive path. As very similar, when you insert your USB, you have a drive assigned to it. When you mount a particular VSD on Azure, you also have a drive path, and further, then you can go ahead and use NTFS file APIs to read, write operations on the drive. And once you are done, you may want to unmount it or delete it. Unmount will only remove the drive mapping, but the data will be present. Whereas if you say delete a particular drive, the associated page blob will also get deleted when you delete a particular drive. Focusing towards the last topic, that is SQL Azure. SQL Azure, as I mentioned several times, is a relational database service by Microsoft using the standard SQL Server. So people who have worked on SQL Server will pretty much feel that it's almost the same thing available on the cloud. The TSQL statements, most of the TSQL statements, barring few, will work in as-is format on SQL Azure. MSDN has a very good information on which statements will work as is, which will work partially, and which will not work. You may want to refer that for more details. The way you access Windows Azure will be through a database manager which is web-based, or even you can use SQL Server Management Studio to go ahead and access it. So if you go here, I already have a database that is created. I go ahead and simply connect to it and say, I choose the database and just say go ahead and manage. Now this opens up an online database manager through which I can go ahead and look into my database, run scripts. I can go ahead and create tables and all that stuff. So if you check this out, this becomes the name of your database. The complete name is this of your database, and then you can pretty much connect to this online and get details of your tables, run scripts, create store procs, and do all your standard SQL operations. At the same time, you can go ahead and use SQL Server Management Studio as well. So from your local machine, if you have internet connectivity, you can go ahead and use SQL Server Management Studio to connect to your Windows Azure database. So if you go to your design, this is the online tool. From here you can see I have a table. I can drop a table. I can create a new table. I can go ahead and see the data for that. These are the various operations that you can do straight away using the online tool. So I can go ahead and change the design if you want of that table and stuff like that. Similarly, from here I can choose, okay, I want to go to this database and use SQL Server authentication. By the way, on Windows SQL Azure, your Windows authentication will not work. It will work with SQL Server authentication. Put your password, go ahead and connect to your database. So coming back to slides, you can connect in two ways, Database Manager and SQL Server Management Studio. It's available in two editions on the cloud. One is the web edition and the business edition. Few important things on SQL Azure is it supports SQL authentication. You can set additional IP level security, that is from which machine you need to go ahead and access the SQL Server. The maximum size that is supported as of now on SQL Azure per database is 150 GB. However, you can go ahead and create multiple databases and shard your application data so that you can use multiple data, partition your data, and then access is possible through multiple databases in case your data grows more than 150 GB. Very interesting. Last two slides for today. How is all this metered and how is all this charged? So more details will be available on Microsoft's site, but just to give you a glimpse, if I talk about the Windows Azure storage, this slide talks about Azure storage. When I refer to Azure storage, I refer to blob tables and queues. The way billing is done is based on pay per use, as I told you earlier. So the billing is based on the average daily amount over a monthly period. So if I use 30 GB of data for 30 days, I'll be charged a billing for 30 GB over a month, which means 30 GB into 0.14 per GB is what my monthly billing will be in case I choose a package of pay as you go. There are multiple packages which are available by Microsoft. You can choose the best available that suits your requirement. So Azure storage charging is in two ways. One is for the data that you store, and second is the number of transactions that happens on your storage. So there are two components when it comes to billing for Azure storage. However, when it comes to billing of SQL Azure, it's only one. Transactions in SQL Azure are not charged. Only the data storage is charged. So, however, the billing here is based on the peak database size in a day. So, and again, that is rolled up to the next billing increment. So in web edition, the maximum supported database size is 5 GB for small applications. For enterprise applications, you can use business editions where the size is 150 GB. Billing increment is 1 and 10 GB respectively, which means if you exceed 1 GB, you will be charged for 2 GB. And the next row indicates the charge. Around $10 per GB per month is the charge that you get onto your cloud. So the references that you can go through, and now I open up for QA. So if you have any questions, you may please pass on the questions to me via the moderator.
Yeah, the questions are already shared with you. You see the questions in the questions pane?
Okay, so I have a few questions. The first question is that has come is, what is the major difference between the storage on cloud and cloud storage? Technically, there is no difference. The complete session talks about how you can store data on the cloud, what are various options that you have? So I might be referring to cloud storage or storage in the cloud. It's one and the same. That's the second question which came in. So that is what I say it's answered. Second question is, what is the level of support of PowerShell? What is the level of support PowerShell gives for APIs you have mentioned? Now, the way you work with Azure, you can talk to the storage account through two things. One, you can use REST. Second, you can use your Windows Azure storage client library. So through the client library or through your REST, you can use the APIs and access the cloud storage. Second question again from Saranya M. This is a general question and not specific to Windows Azure. An application is migrated to an instance to the cloud. Lift and shift of the app. How do application get connected to the cloud storage? Otherwise, how do they store data? Okay. Now, when you go ahead and want to migrate your application on the cloud, you'll have to implement some strategies for migration. The first thing could be you keep your data on premise and migration only your web part or the web application to the cloud, and the data can remain on premise. Then there is no change in the configuration. However, if you want to migrate data as well to the cloud, you may want to change your data layer and make sure that you go ahead and use appropriate the client APIs in your data layer and point your connection string to the cloud storage. Earlier, your connection could be to a particular storage, but now you'll have to point that to some storage in the cloud. Another question is, what is meant by put blob operation? Put blob operation is the method which is available in the APIs provided by Windows Azure through the storage client libraries. The way we call some APIs for some file IO operations, similarly, put blob is one of the method that is there from the storage client library. What if a client has an Oracle or DB2 server in place of SQL? A very good question from Murli Iyer. In case, now I've told you all the options which are supported by Microsoft. Microsoft can support blob tables, queues, drives, and SQL Azure. However, there is no restriction on where your application can connect to. In case your application wants to connect to Oracle or a DB2 server, your application can be configured to connect to on-premise Oracle or DB2 server, or it also could be talking to Oracle or DB2 server which is available on some different cloud which is a non-Microsoft cloud. So as of now, I am not very sure whether they are supported, but most probably they are not supported. So your option for Mulli remains to continue with your on-premise servers for Oracle or DB2, or go ahead and host it in some different cloud. So data can remain in another cloud, whereas your application can go on your Windows Azure. Do you think Windows Azure has limitations over storage? As I told you, there are no such, I don't feel you have a limitation on that, but probably yes, you have to change your design. For instance, when I told that today the maximum size of SQL Azure database which can grow is 150 GB, which means for an enterprise level application, 150 GB probably may be a small size. In that situation, there is a way to work around that, and the way is you'll have to shard your data, you'll have to partition your data so that multiple databases are used. Under one server, you can create up to 150 databases into one SQL Azure server. So that multiplies the amount of data you can store under one server. So Yes, looking at the current size, 150 is what you'll have to use if you have more partition your data. However, if you have huge amount of data, then a good option could be you go ahead and start using your blobs, tables, and queues, because if you see you have good amount of data that can be stored into blob. A single blob can go up to 200 GB, whereas a page blob can go up to 1 terabyte. So you will have to design your application to overcome the limitations if there are any. Question is from Arjun Kumar. I am using local storage for storing data. Does that still remain in storage if the role is restarted? Local storage is a good question again. Local storage is an option where you can use a part of your virtual machine to store or cache information. The size of the local storage that can be there depends on the size of your virtual machine. Now, when you create local storage, you have an option. Do you want to recycle the data when you restart your role? So if that option is set to true, then the data will be recycled when the role restarts. However, Microsoft always recommends that if you want to store something in a persistent fashion, we should not use local storage. Instead, we should go ahead and use page blobs to do that. But yes, you can use local storage for volatile data. How can we ensure data security? A very valid question, Bhupesh, but he has, I guess, left. But just to answer it, from a security perspective, we will have to use .NET APIs to make sure that the data is encrypted and then sent to the storage. The storage will not give out-of-box encryption support. So it's a developers or the architect's activity to make sure data is encrypted, sent to a data store, and when you read it back, you decrypt it and read it. Girish Kumar, a question. Girish Kumar asked whether any browser is completely compatible with cloud computing. Now, cloud computing is a platform where you can host your applications, you can utilize services, you can access or ensure connectivity between various applications. So I don't think there's a issue of cloud computing with the browsers. It purely depends on what kind of application you host onto your cloud. So if your application which is hosted on the cloud is purely supported by the latest browsers, then absolutely no issue. So it depends on the application you host on the cloud. How to check the version of the currently loaded runtime on Azure worker node? So if you go to the Azure properties of a running role, for example, if you select your node of your service of your application, for that service you will get to know the details of the configuration that are used. You will get to know what is the storage that is getting used, as well as it gives you which version of SDK is using. The current SDK is 1.6, dot the minor version. Guidance on Windows Azure certification and books, asked by Amit. Amit, there is one certification which is hosted by Microsoft on Windows Azure. You can just, I don't recall the number, I guess it's 580 or something like that. You can Google on that and get the detail. But Microsoft gives you one certification on Windows Azure, and for which you also have a learning map which Microsoft recommends to prepare yourself. It points you to various learning artifacts on this topic. Does Microsoft provide any demo accounts for storage? I guess no. You'll have to use appropriate subscription through which you can get access to Microsoft accounts. Is there a difference between Amazon Elastic Cloud Compute and Windows Azure Service? Amazon I have not worked much, but if Anshuman can precisely tell me what he's looking for, what feature in Amazon he's looking on to Azure, I can answer that. If Anshuman can tell me about what features are available in Amazon, definitely yes. There would be some, or most probably they will have some equivalent for that on most of the cloud providers. What about loading time of applications using Azure? It depends on the application that you host. Standard application would take, and it also depends on the internet connectivity. So for me, sitting in India, it takes me around 2 to 5 minutes max to host an application of sizable capacity. It is a valid and possible Azure QA. Varsha Srivastava, I don't know to get your question. The question text says, is this a valid and possible Azure QA environment? Now, when you host your application, it goes in 2 stages. The first thing, you go ahead and host it onto your staging environment if you want. You test it there, and from the staging environment, you move your application to production. So in both situations, the billing remains the same. That is the important point that you may want to note. Other than pay and use, either any hidden cost factored in SLA deposits and guarantees as a Moodley here. Apart from the metered cost, there is no other hidden cost. At least I could not incur that for the past 1.5 years. I'm using the Azure account since almost 2 years now, but I have not seen any hidden cost. It gives you a complete bill on the Azure portal. You see a complete bill. If you understand the billing properly, the billing happens in various things. Billing happens for your storage, billing happens for your transactions, billing happens for data transfers, and along with that, the billing also happens for your roles, the compute instances, CDN. So if you take all this into picture, this is what your Azure billing is charged for. The details of that will come day-wise, service-wise into your Azure bills. Is SSMA, I believe SSMA, what Jayesh is referring to is SQL Server Migration Assistant. Yes, it is compatible with Windows Azure. How to check staging or production by II setting from EXE on Azure? I'm not very clear with the question from Varsha, but when you go ahead and deploy your applications, you have to choose where do you want to deploy it. It will ask you while the deployment happens, do you want to deploy it on staging or do you want to deploy it on production? Once you deploy it on staging, you can do a swap. There's an option called as VIP swap on the top of your Azure portal. Through that, you can do a swap of your application from staging to production. Any additional storage services like data compression, snapshot. Yeah, you can take snapshots, but again, when you take a snapshot, you will be required to store that snapshot to the storage, which will add to extra code and extra cost. Azure, it's a question from Akash. Azure is storing data in encrypted format. So does it mean for every query, whole data will get downloaded? No problem like query, etc. I've already shown a small code snippet where the data gets downloaded, where you can download the data based on what you require. It depends on how you fire your queries. Another thing, Azure will not store data in encrypted format. You will have to encrypt that and store it into Azure. Blobs, can we have less than 4 MB each block? Yes, you can have. 4 MB is the limit for the blocks of a blob. I repeat, 4 MB is the limit of every block in the blob. Less than that you can have. How scalable is Azure for VDI? Or what is VDI? Pratyush needs to explain what is VDI. When it comes to scalability, when you deploy your Azure applications, you can specify that the application should run in one instance or it should run in multiple instances. So if you specify that your application, you want multiple instances to run, that's how on-the-fly scalability can be achieved. So if my load is high, I can go ahead and add more roles, and as soon as the load increases, I can reduce the number of roles to reduce the costing. So for running application, I can go to the portal and I can go ahead and add or remove the number of instances on the fly while the application is running. And here is the last question. Is there a specialized process to migrate access data to SQL Azure? Yes, Jayesh, you can go ahead and migrate your data from Access to SQL Azure. What you'll have to do is there is a migration assistant tool for Azure. You have to go to windowsazure.com and go to the developer tab. On the developer tab, you will have various tools to download. One of the tools that you can download for your requirement is the migration assistant for Windows Access, so Microsoft Access. So using that tool, you can go ahead and migrate your data from Access to SQL Azure. So any more questions? Whatever questions I have received, I have finished answering all the questions. So if you have any other questions, I'll wait for another 2 minutes, or we would like to end this session here. So another question is from Saranya. How is data recovery implemented? Now, it's a very good question. In fact, I would have loved to answer this question if this would have been commented first, so that most of you could have benefited onto this. When it comes to data, what Microsoft does is, if you have noticed, when I created a storage account, I had chosen a particular region where my account is to be created. From a disaster recovery perspective, Microsoft will go ahead and replicate the copy of your data into another data center in the same region. I repeat, so if you choose Southeast Asia to create an account, whatever you do there, Microsoft will replicate that storage account's information, including the data, into another data center in the same region. Now, why in the same region? Because there could be some rule of the land to ensure that the data is not stored outside the geography. So that's where seamlessly the data gets replicated. Now, in case your primary storage is down, the primary storage is where you created the account. In case the primary storage is down, automatically you will be your request will be pointed to the secondary storage, which the Microsoft will have already replicated your data. On the Windows Azure portal, you can see where your primary data resides. Do we have import export wizard like we have in SSMS? Yes, that's answer to Nagesh Sawant. You have an import export wizard in SQL Server Management Studio where you can generate scripts very specifically if you want to migrate to SQL Azure. So if you have an on-premise SQL Server, you can generate scripts very specific to SQL Azure. You have an option in SQL Server Management Studio which can generate the scripts, and from there you can go ahead and run the scripts on your SQL Azure to make sure that the same structure gets created on SQL Azure. Any other questions?
I think most of the questions are answered, so we can conclude the session now.
Okay. So thank all of you. I'm not sure how many of you are still there on the session, but it was nice sharing my information, sharing this information with you all. So please pass on your feedback to the moderators. Thank you. Thanks, Keshav.
Thanks, Mr. Nilesh, for your informative session on cloud storage for Azure application. It was indeed an enlightening session. I would also like to thank our participants for their support in making this webinar a huge success. The recording of this webinar will be available on techgeek.com by tomorrow. The next session in Cloud Computing webinar series is happening on Wednesday, 25th January at 3 p.m. Topic of for the webinar is Cloud Computing Strategies for Enterprise. We will be having Mr. Shankar Verma, Practice Manager at Yash Technologies as our guest speaker. So see you all on Wednesday. Thank you.